In this video, we're going to talk about solutions. We cannot talk about equations without their solutions. So, a solution of a linear equation in n variables is a sequence of n real numbers s sub 1, s sub 2, s sub 3, up until s sub n arranged to satisfy the equation when you substitute the values x sub 1 is to s sub 1, x sub 2 equals s sub 2, x sub 3 equals s sub 3, and so on until x sub n equals s sub n into the equation. So the equation that we are referring to is the equation a sub 1 x sub 1 plus a sub 2, there you go, a sub 2 x sub 2 plus a sub 3 x sub 3 plus until plus a sub n x sub n equals b. So there. So the first part of this definition is telling us that if I substitute this with s sub 1, this one with s sub 2, this one with s sub 3, up until this one with s sub n, and the equation is satisfied when I evaluate this expression, multiply a sub 1 to s sub 1, then add and all of that, and it's equal to b, then we call these numbers actually our solutions. So the set of all solutions of a linear equation is called a solution set. And when one has found the set, one has solved this equation. So there you go. To describe the entire solution set of a linear equation, we have to use what we call a parametric equation. Now, in simple linear equations such as x plus 2 equals 3, this is very simple. We use the basic rules of algebra where we can transpose this one. X will be equal to 3 minus 2, hence x equals 1. Thus, the solution set will just be the set containing 1. However, there are linear equations wherein we need to figure out what are the numbers or the structure of the numbers that belongs in that set that can solve the specific equation, especially if our linear equation contains more than one variable. So let's have a specific example. So we are asked to solve the following linear equations. First one is x sub 1 plus 2x sub 2 equals 4. So in this item in number 1, wait a moment. It's better to write it here first. There you go. So we have to solve, or we have to get a solution to this one. And we're not used to the fact that there are two variables to solve with just one equation, because that will not give us an actual number. But let's try it. So the usual thing that we do is we leave the variable here. Let me just rewrite that equation there. And then what we usually do is we transpose this number here to the other side so that our usual notion is that x equals something. So we'll do that. We'll have x sub 1 is equal to 4 minus 2x sub 2. And here we're stuck rather, and we're wondering, now what is the answer? So this x sub 2 here can actually be replaced by any real number, because this is actually what we call a free variable, wherein any real number you can place that we can actually get an answer. While this one, x sub 1, is not free because it is defined to be a number that you can get only when you get the difference of 4 and 2 times, well, any number. So in this case, we can see that there's more than one solution. In fact, infinitely many, because we can use any real number. So to show that this equation has infinitely many solutions, or there's a lot of solutions, we have to let x sub 2 be a symbol that can represent any real number. It's usually letter t. Then we write this variable t is an element of the set of real numbers, which means that x sub 2 can be any number t which is a real number. And we call this our parameter. And then we would have our x sub 1, I'll just write it here, is actually equal to 4 minus 2t, wherein t has been defined a while ago to be x sub 2 would be an element of the set of real numbers. So, writing it down formally, I'll just write it here. Our x sub 2 is equal to t, which is an element of the set of real numbers, and x sub 1 will have 4 minus 2t. So, this is indicating that this equation has actually a lot of solutions. In fact, infinitely many, because, well, we have infinitely many real numbers to substitute to t. So, to show that there are some particular solutions, when we say particular, we mean specific. Say, for example, if we will let t be equal to 1 and t be equal to 0. So that means my x sub 2 will actually be equal to 1, and my x sub 1 will be equal to 4 minus 2 times 1, which is equal to 2. That means x sub 1 equals 2 and x sub 2 equals 1 is a particular solution. If t is equal to 0, then automatically my x sub 2 is equal to 0, and my x sub 1 will be 4 minus 2 times 0, which is actually equal to 4. So x sub 1 equals 4, x sub 2 equals 0 is another particular solution from the general solution of our equation. And this is actually what we call our parametric equation. I don't have space. So there you go. So what about for number 2? Let's just bring this down. So we'll have number 2 there. Alright, so our number 2 is 3x plus 2y minus z equals 3. And we're asked to solve for x. So generally, what we can do, we have to transpose this two terms here on the other side. So we will have 3x is equal to 3. Remember to change the sign. Minus 2y plus 2. 3 is not yet alone because we still have 3 here. So divide everything by 3. Hence, this is z. It looks like, there you go. So it will look like z. So therefore, x would be equal to 3 minus 2y plus z all over 3. And as you can see, we have two free variables, y and z. Therefore, we can assign y to be, say, t be an element of the set of real numbers, and z be equal to u, where u can also be another real number. It can be the same as t, it can be different as t. While our x will be defined as 3 minus 2t plus u all over 3. Basing the fact that t and u are these two predefined numbers already. And this is our solution to this specific equation. It doesn't need to be written in order actually, because anyway it would mean the same. So these are some of the examples of how we solve linear equations. So here are some more equations to solve. Kindly solve the following equations, and we're going to show the solution in the next video.